All right, good morning, everyone. So today, for those of you who are at home, we're going to shift out of sampling for a little bit and talk about some experimental design. Now, experimental design for stats is a lot different than when you're talking about experimental design for a science class, say. But the ideas here are still basically the same. The one thing you'll tend to notice is that our definition tends to be significantly more broad. Whereas if you think about a sample, many of you who are taking psychology said that a population was a group of people. Well, in our class, a population is really just a group of anything that you want to study. So again, the idea being that our definitions tend to be a lot more broad, as we could be dealing with anything. It might be people, it might be cars, it might be plants, it might be whatever. So first, let's talk about, for our definition here, what actually is an experiment, right? So our definition here is, for an experiment, it is just a controlled study to try and establish a cause and effect relationship. Now, one thing that's important, when we've been talking about samples so far, those samples are observational studies. I'm not manipulating any variable. I'm handing someone a survey, I'm asking them to fill it out, and they're handing it back to me with their questions answered. Biggest difference now in an experiment is now I'm going to control some things. I'm going to keep everything constant, but just manipulate one specific variable to see, does this have some sort of effect, right, on whatever my measurable outcome is. So there's an important thing here in terms of our variables. We still have an explanatory variable, which in this case is whatever I'm manipulating. When I say I really mean the experimenters. We still have our response variable, which is what our experimenters are measuring. So for instance, if I'm trying to determine the impact of a certain dosage of caffeine on heart rate, my explanatory variable is going to be the amount of caffeine. The response variable in that particular case is going to be heart rate. So I'm going to give different groups of people different dosages of caffeine, and then I'm going to measure their heart rates. So that is my response variable. Now, experiments introduce a new type of variable for us, which is a confounding variable. And what a confounding variable is right, the name doesn't sound great. What it does is it has an effect on your outcome, but it wasn't controlled for. So, for example, using the caffeine and heart rate study, maybe you have a particular individual in your study who is an Olympic level swimmer. So by default, their resting heart rate will be significantly lower than your average person. This is a potential confounding variable if we don't try and take into account the fact that their starting point is different than everyone else's. It may skew my data to show that caffeine has less of an effect because their heart rate is already low to begin with. Their heart rate, when it's quote unquote elevated from caffeine, still won't be nearly as high as your standard person. So that's one example of a confounding variable. This is a very big topic that we'll spend a good amount of time talking about. We try and control for these as best we can, but obviously it is impossible to control for them 100%. So the idea is it's just some sort of outside variable that may affect your results, but we didn't control for it at the beginning, or we were unaware that we needed to. So then we get into the really, really important stuff, what we're going to call the 4 pillars of our design. And these are 4 things that every experiment should have. The first one is a comparison of at least 2 treatment groups. Now, a treatment here is just whatever variable we're trying to manipulate, we're going to create groups of people. Right, so for my caffeine dosages, maybe I have a treatment group that gets 100 milligrams of caffeine, a treatment group that gets 200 milligrams of caffeine, and a third treatment group that gets 300 milligrams of caffeine. Now, the other important thing here is that one of these groups can be a control group. Right, so maybe I have one group in that caffeine study that gets decaf coffee with significantly less caffeine, or they get nothing at all. We just give them water to drink instead of coffee, something along those lines. The second important thing is that we have random assignment. Now notice the difference here. Random assignment. With an experiment, I was trying to create or collect a random sample. With an experiment, it's going to be really hard to randomly select the people in your experiment. Right? I can't just fly all over the country and tell someone that, come on, you're coming with me back to New York, even though you live in Alaska, because you were selected to participate in my study. So the way we make up for that is that we randomly assign treatments to subjects. And this order is very, very important. Each individual within your study or within your experiment, whether that's a person, whether that's a car, whether that's a plant, whether it's a hamster, whatever it may be, you are randomly assigning a treatment to that person, not the other way around. So you're not randomly assigning a person to a treatment group. You're randomly assigning the treatment to the person. So the way that I think about this is as I move down the line, if I lined up everybody in my study along the wall, right, I'm going to go to the first person and flip a coin. Whatever it lands on, that's the group they're in. Go to the next person. Flip a coin for them. So you're flipping a coin for each person. You're not flipping coins standing in the experimental group to pick people. Each person has the same percentage chance to be in any group as anybody else. The other important thing is that we have replication, which means we have more than one subject in each group. And so within each experimental group or within each treatment group, you have more than one person, so we have something to compare these people to. Right? This stands to reason anyway. You're probably not going to be able to draw a great conclusion if you only are creating this environment with one person. Right? Not very many people are going to take your study seriously because it's only one person. And the very last thing is that we are controlling for confounding variables when necessary. Obviously when necessary, because some experiments may not be influenced by a ton of confounding variables. It all depends on the nature of whatever experiment you're trying to carry out. So this has been the very basic intro to experimental design. What we will talk about next week are the different types of experiments you may see. We have 3 different design types, as well as the idea that many of you are probably familiar with, which is like single blind and double blind studies. So we'll talk about those. Your work for today is just going to be very short. It's just a free response question about sampling. So I hope you guys have a wonderful weekend, and I'll see you next week. Bye, guys.